When NASA's OSIRIS-REx spacecraft collected samples from asteroid Bennu's surface in 2020, forces measured during the interaction provided scientists with a direct test of the poorly understood near-subsurface physical properties of rubble-pile asteroids. The low gravity of rubble-pile asteroids such as Bennu weakens its near-subsurface by not compressing the upper layers, minimizing the influence of particle cohesion, said SwRI's Dr. Kevin Walsh, lead author of a paper about this research published in the journal Science Advances. We conclude that a low-density, weakly bound subsurface layer should be a global property of Bennu, not just localized to the contact point. Fitting its designation as a rubble-pile asteroid, Bennu is a spheroidal collection of rock fragments and debris 700 feet in diameter and held together. It is thought to have been formed after a collision involving a larger main asteroid belt object. Rocks are scattered across its heavily cratered surface, indicating that it has had a rough-and-tumble existence since being liberated from its much larger parent asteroid some millions or billions of years ago. The goal of OSIRIS-REx, origins, spectral interpretation, resource identification, and security regolith explorer mission is to collect and return at least 60 grams of surface material from Bennu and deliver it to Earth in 2023. According to Walsh, researchers involved in the OSIRIS-REx mission have so far measured Bennu's thermal properties and craters to estimate the strength and porosity of discrete particles of rubble-pile asteroids. The ensemble of particles, or regolith, at an asteroid's surface controlling and influencing long-term evolution have not yet been probed directly until now. Before, during, and after the sampling event, the Sample Acquisition Verification Camera (SAM-CAM) of the OSIRIS-REx camera suite captured images looking at the touch-and-go sample acquisition mechanism, TAGSAM, robotic arm. Nearly every visible particle is moved or reoriented at all points along the circumference of TAGSAM up to a 15-inch radius. These SAM-CAM images showed the downward force of TAGSAM lifted a nearly 16-inch rock. Though strong enough to withstand braking, the rock was reoriented and small debris lofted off its surface. The mobility of these millimeter-scale particles under relatively weak forces suggests minimal cohesive bonding with the surface of the larger rock. Scientists have theorized that the average regolith particle size increases as asteroid size decreases, because larger bodies retain smaller materials due to a higher surface gravity. The team then compared Bennu to similar rubble-pile asteroids. We discovered a dichotomy between the rough, boulder-covered surfaces of Bennu and Ryugu versus Itokawa, which includes ponds of smaller particles across 20% of its surface, Walsh said. This could have several explanations, including that the latter's near surface has compressed enough to frustrate these microparticles percolating into the interior, or perhaps the granular deposits or subsurface layers revealed by a recent disruptive reorganization of the body. A companion paper. Note: content may be edited for style and length. Journal reference: Kevin J. Walsh, Ronald Louis Belouz, Erica R. Jahan, Krissa Avdelidou, Olivier S. Barnouin, Karina A. Bennett, Edward B. Bierhaus, Brent J. Boss, Saverio Cambioni, Harold C. Connolly, Marco Delbo, Daniela N. Della Justina, Joseph DiMartini, Joshua P. Emery, Dathan R. Golish, Pat. Near-zero cohesion and loose packing of Bennu's near-subsurface revealed by spacecraft contact. Science Advances, 2022. 8/27, doi. 10. 1126, SCIADV. ABM 6229. Cite this page, Southwest Research Institute. New insights about surface, structure of asteroid Bennu. OSIRIS-REx data indicates surface, near subsurface rubble is loosely bound. Science Daily. https://ift. TT, AFJBRNW. Access July 7, 2022. Thanks for watching. Please subscribe my channel for more videos.